Hi students, good morning. Welcome to our video classes. In the previous classes we have learnt melting, boiling. These are the phenomena, that means change of state of matter and the effect of pressure on the state of matter. Today we are going to learn about another phenomenon, that is evaporation. What is this evaporation? This is the daily phenomenon which is observed in our life. Okay. Simply in this, the liquid phase is converted into gaseous phase. How this liquid without heating, that means it is done at any temperature, but in the case of boiling, the liquid phase is changed into gaseous phase at a constant temperature, that is at its boiling point. But in the case of evaporation, this liquid phase is changed into gaseous phase at any temperature below its boiling point. For example, wet cloths dry, and if the room of our house is washed, that water disappears. Where does this water go? Into the atmosphere. By which phenomenon? Evaporation. Simply, what is this evaporation? In this, liquid phase is converted into gaseous phase at any temperature. On that, the temperature is 27 degrees Celsius or 30 degrees Celsius or 40 degrees Celsius or whatever may be the temperature. At any temperature, this phenomenon is done. Actually, how it is happened? Just observe. If any liquid is there in the beaker, these particles of that liquid have energy, that means internal energy. Due to this internal energy, always these particles are in motion, that means they have kinetic energy. And how they move? They move in different directions in straight lines, what we call as random motion. Due to this random motion, these particles collide with each other. Whenever this is called random collision. Whenever these particles are collide with each other, then the energy is transferred from one particle to another particle. Like that, these particles collide with each other, and the internal particles collides surface particles. Okay, that means these surface particles gains energy. Already we have learned that liquid has a free surface. These surface particles gains energy. That means from internal particle to internal particle, and from internal particle to surface particle, these surface particles gains energy. And due to this higher energy of the surface particles, they escape from the surface of the liquid. And whenever they escape from the surface of the liquid, what is happened? Above the surface of the liquid, again air is there. Some of the escaping particles collides with the air particles and returns back into the liquid. But most of the particles escape from the surface of the liquid. Simply this process of escaping of molecules from the surface of a liquid, simply it is called as evaporation. Okay, and during this evaporation, what is happened? The surface particles lost energy. That's why this evaporation is a cooling process, and it is a surface phenomenon, and it is a cooling process. Let us observe some examples to show that evaporation is a cooling process. For example, take some acetone, nail polish. What is used as nail polish? That is acetone. If you put a few drops of acetone on your palm, how do you feel? We feel cool. How this is happened? This surface particle, this acetone disappears after a few minutes or few seconds. It disappears, and not only that, we feel cool at that spot. Okay, why? These surface these particles of acetone escaped from our palm. That means evaporation. And whenever these are escaped, they gain energy, what is needed for evaporation, and that energy is absorbed from the surroundings, that means from our palm. That's why we feel cool. And not only that, we observe this cooling process in our day-to-day life. For example, in summer season, water stored in matka pot, new matka pot, that remains cool. How it is happen? For this new matka pot, what are the small pores are there? From these small pores, that water is secreted just like droplets, and these water droplets are evaporated. For this evaporation of these particles, energy is needed. Okay, why? Whenever they gain sufficient energy, then only that are escaped. That means this energy is needed. This energy is absorbed from the surroundings. That means the surrounding particles, the surrounding air particles which are surrounding around the part that are air particles losses energy, that means that are cooled. Whenever the surrounding atmosphere of this pot is cool, then the water in the pot remains cool for a long time. Like that, the water in the new matka pot remains cool. Okay, and in so many activities it is observed. For example, whenever we do physical exercise or hard work, we get sweat. If the sweat is evaporated, how do you feel? We feel cool. Okay, and again, how it is happened? That means when we do physical exercise, some energy is utilized. Okay, that energy, that means we utilize some energy. That energy is absorbed by the water particles which are present in air and escaped from our body through the reaches to the surface of the body through sweat pores. Whenever the water comes out from our body to the surface of our body through the sweat pores, not only that water is coming along with the water particles, what we call as sweat, that some internal energy is also absorbed, and this sweat is evaporated. That means energy is escaped to surroundings. That means energy is transferred from internal body to surface body and from surface body to atmosphere. Like that, the energy of the body decreases, heat energy here. That's why we feel cool. That's why we prefer to wear cotton clothes in summer. Why? This cotton clothes absorbs more sweat. Whenever it absorbs more sweat, then it evaporates easily. That's why we feel cool. This is evaporation. But this evaporation is quite different to boiling. Boiling means that is done at boiling means that is done at constant temperature, at its boiling point only. That means the liquid phase is converted into gaseous phase at constant temperature. But in the case of evaporation, this liquid phase is converted into gaseous phase at any temperature below its boiling point. This is the main difference. And not only that, in that boiling, what is converted into gas, that steam, it causes more severe burns than boiling. Why? It absorbs energy in the form of latent heat of vaporization. Okay, and that is a bulk process. But here this evaporation is a cooling process and it is a surface phenomenon. Why? These surface particles are only escaped. Why? If we left some water, some water is there which is uncovered, that disappears. That means from day to day its surface level decreases. That is due to evaporation. That's why this evaporation is a surface phenomenon. Okay, and some factors are there which affects this evaporation. What are that important factors affect the rate of evaporation? The main important factors that affect the rate of evaporation are surface area, temperature, humidity and wind speed. Let us learn how these factors affect this rate of evaporation. First, about surface area. While the wet clothes are dried, how these wet clothes are dried? That are in the bulk of that clothes? No, that are spread. If they are spread, what happens? That gets dried easily. That means the surface area of the cloths increases. Whenever the surface area increases, then automatically this rate of evaporation also increases. Let us observe this with some activities. Take same amount of water in different containers. One is wide-mouthed jar, just like a shallow vessel, and the other is narrow-mouthed jar. Okay, that means one is china dish and the other is test tube. Take same quantity of water in these two and place these two at the same condition. Same conditions means same temperature, same humidity, same wind speed. After a few days, if you observe these two bakers, in which baker less amount of water is there? In the jar which is wide-mouthed, which has wide mouth. But in the test tube, we observe large amount of water. Why? That means in the wide-mouthed jar, surface area is high. If surface area is high, then automatically the rate of evaporation increases. Why? If surface area is high means more number of surface particles are there. That means there is a chance to escape large number of particles at an instant. Okay, like that, if the surface area increases, then automatically rate of evaporation also increases. But in the case of narrow-mouthed jar, the surface area is low. That's why at any instant of time, less number of particles are escaped from the surface of the liquid. That's why rate of evaporation decreases. Like that, this surface area, this evaporation depends on surface area. Next, another factor that affect the temperature is affect the evaporation is temperature. How this temperature affects? If temperature is high means the water vapor, more amount of water liquid is evaporated. That means rate of evaporation increases. How it is happened? Temperature is high means the kinetic energy of the particles is high. That means more amount of kinetic energy is there. If more amount of kinetic energy means there is a greater chance to escape large number of particles. Okay, that's why on a hot summer day more amount of water vapor is present in the atmosphere. Okay, that is due to higher kinetic energy. That means if temperature increases, rate of evaporation increases. Temperature decreases, rate of evaporation decreases. Next, other factor, that is humidity. What is humidity? We know the main important components in air are nitrogen, oxygen, carbon dioxide. Besides these, water vapor is also present in the air. Okay, that means this amount of water vapor present in air, that is called as humidity. This humidity also affects the rate of evaporation. How it affects? If humidity is high, rate of evaporation is low. Why? The air which surrounds us cannot sustain a large amount of water vapor. That means only a fixed amount of water vapor may be present in it. Okay, if it is saturated, that means if the air with this water vapor is saturated, then it cannot hold more water vapor. Okay, that's why if it is a hot in summer season, we feel sultriness. This sultriness is caused due to higher humidity. That means in the summer season, if anybody touches with us, okay, don't touch like that, we feel sultriness. Why do we feel that sultriness? Due to higher humidity. That means more amount of water vapor is there in the air. Then there is no chance to escape large number of particles from the surface of a liquid. Like that, the rate of evaporation decreases. Okay, and other factor is wind speed. How this wind speed affects? For this, for example, if the floor of our rooms are washed, in one room the fan is turned on, and in other room the fan is switched off. Then in which room the water disappears fastly? In which the fan is working. Okay, why? That means wind speed is high. Whenever the wind speed is high, the rate of evaporation increases. That means when the particles are escaped from the surface of a liquid, then due to this wind speed, these particles are drawn out from the vicinity of the surface. Whenever that are drawn out from the vicinity of the surface, then there is a chance to escape some other particles from the surface. Like that, when the wind speed increases, the rate of evaporation increases. This is experienced in our day-to-day life also. When clothes are dried, if wind speed is high, then that gets dried up fastly. If wind speed is low, it takes some more time to dry the clothes. That means here wind speed affects the rate of evaporation. Okay, this is the important phenomenon, that is evaporation. I hope that all you understand. Okay, again practice about this unit. What is melting point, what about the melting points of different substances, what is boiling point. Try to collect the boiling points of different substances, and why there is difference between the boiling points of all these substances or melting points of all these substances. In this view we have to prepare. Okay, thank you.